In this session, we will discuss some basic concepts in osmoregulation and its importance. Let's start by defining osmolarity. Osmolarity is defined as the concentrations of osmotically active substances in a solution. It is normally expressed in osmoles of solute particles per liters of solvent. For example, 1 molar solution of sodium chloride is equivalent to 2 osmolar solution, or 2 osmotically active particles, because sodium chloride dissociate to become sodium ions and chloride ions in water. Normal human blood plasma osmolarity is approximately 290 to 300 milliosmoles per liter. For example, freshwater aquatic vertebrates may have slightly lower plasma osmolarity, probably less than 260 milliosmoles per liter. Whereas for some of the marine vertebrates were reported to have much higher plasma osmolarity values, about 800 or greater than 800 milliosmoles. So just to let you know that the osmolarity of seawater is approximately 1000 milliosmoles per liter. So next, let's take a look at what is osmoregulation. It is a process of regulating solute concentrations or balanced movement of solute between the internal body fluids and the external environments. So do you know why this process is very important in animals? So despite the strong challenges from an animal's external environment, for example, hibernating animals during cold winters, or animals that live at very dry or arid climates, the animal's body waters and solutes at cellular levels must be held constant within a narrow limits in order to maintain homeostasis. So there are two categories of animals in terms of osmotic challenges: the osmoconformers and the osmoregulators. Osmoconformers are animals whose internal osmolarities change in relation to their external environments. So these animals, such as most of the marine invertebrates, usually live in a stable environment. And any large fluctuations of the external environment or the external osmolarity will cause death. On the other hand, osmoregulators are animals whose their internal osmolarities can be maintained within a tolerance limits, regardless of the external salt concentrations. Human, for example, marine vertebrates as well as freshwater or many other terrestrial organisms are actually under these categories. Animals can also be categorized into stenohaline and euryhaline. Steno means narrow, while haline means salt. The stenohaline is organism that cannot tolerate a wide variations of salinities of the surrounding water. For example, goldfish die immediately in high salinity environment, whereas tuna, a very strictly marine fish, is also stenohaline and die in a water with a very low salinity. Euryhaline organisms, on the other hand, can tolerate a wide range of salinities. They usually spend part of their life cycle in a freshwater and part in the seawater. One very typical example is salmon. Salmons are evolved to have osmoregulatory mechanisms that survive in a wide range of aquatic environments, varying from freshwater to blackish water to sea waters. So we have discussed several terminology related to osmoregulation, which include osmolarity, osmoconformers, osmoregulators, steno and euryhaline. So one question to ponder: why do salmon spend part of their life cycle in freshwater system and part in seawater? So salmons are facing some serious physiological challenges to keep their body fluid concentration within a homeostatic limit. So can you discuss osmoregulatory problems for salmon and how salmon cope with this during their life cycles?